In the previous lecture, we have discussed that the chemical equation Mg plus O2 is equal to MgO. Now we will go for another definition, that is called skeletal equation. Skeletal equation. Skeletal equation, the equation in which the number of atoms of different elements on the reactant and product side are not equal is called skeletal equation. This is skeletal equation. For example, H2 plus O2 gives H2O. In this equation, you see that hydrogen is balanced but oxygen is not balanced here. So this equation is called skeletal equation. After this, we move on to the characteristics of chemical reaction. Characteristics of chemical reaction we will study here. Characteristics means how to know that a chemical reaction is taking place. Chemical reactions. In this topic, you can say that the easily observable changes which takes place as a result of chemical reactions are known as chemical reactions. Some are known as characteristics of chemical reaction. Some of them are characteristics. First one, we will say evolution of gas. Evolution of gas. Second characteristics is change in state. Change in state. Third characteristics of a chemical reaction is change in temperature. Change in temperature. Fourth characteristics is change in color. Change in color. And the fifth one is formation of precipitate. Formation of precipitate. One by one we will discuss. First one, evolution of gas. In this one, we will perform an experiment in which we will take a conical flask, here cork in which two holes are made. First of all, here the zinc granules. We will take zinc granules here, small pieces of zinc, and this one is thistle funnel. From which we will pour acid into it. And second hole is for delivery tube, which moves into another container, or we can say the beaker here. in which a soap solution is placed. A soap solution is placed here. This is delivery tube. This one is thistle funnel. The liquid acid is being poured from here. This must be dipped into the acid so that when the reaction takes place, that is zinc solid, when reacts with dilute sulfuric acid. So for aqueous it is gives ZnSO4, again it is aqueous, gives hydrogen gas. This hydrogen gas formed here passes through this delivery tube and moves here to the soap solution. Here the gas forms small bubbles which comes out like this, and we take a burning candle near this bubble. You see that it blasts with pop sound. There is a blast with pop sound. Blast with pop sound. It means that is hydrogen gas produced here. This hydrogen gas forms bubble trapped into the soap molecules, soap bubble, and this, when a burning candle is brought near to this blasts with pop sound. This also confirms the formation of hydrogen gas. This is one of the characteristics, that evolution of gas. Second one is change in state. Change in state. Simply state solid, liquid or gas. First of all, with the example we will start here. H2 gaseous, oxygen gaseous, forms water. This is liquid. State is being changed here. Here gaseous reactants are there, but the product is liquid. One more example I will take here. Lead nitrate, PbNO3 hold twice, again aqueous, reacts with 2 potassium iodide, which is again aqueous here, gives lead iodide solid plus potassium nitrate aqueous. This is also a precipitate, PPT, solid substance. It will settle down. We can write like this also. So we'll discuss further. Next topic. Here this is the change of state. You can see both are aqueous here, but here solid is found. Again a change of state. Now the third characteristics we will discuss here, that is change in temperature. Change in temperature. Change in temperature. Again we will take examples here. Two types of reactions will occur. In one case the energy is being taken in, and in one case the energy is given out. Exothermic and endothermic. Exothermic heat is given out and endothermic heat is taken. The two examples we will take here. First of all, again we will take zinc solid plus HCl aqueous, the reaction ZnCl2 aqueous, then hydrogen gas, then heat is being formed here. This is exothermic reaction. Exothermic. Now after this, calcium hydroxide quicklime, which is also known as quicklime, when reacts with water gives calcium hydroxide. This is calcium oxide, this is calcium hydroxide. This is also known as slacked lime. Plus heat is being formed here. Again, exothermic reaction. Quicklime, this is quicklime, and this one is slacked lime. Now one more example, endothermic reaction. Suppose nitrogen gas reacts with oxygen gas. It requires heat for the reaction. We may write like this also. This gives nitric oxide endothermic reaction. Why we are saying endothermic here? Because this is absorbing heat. Heat is being taken, and in this case heat is given out. Barium hydroxide plus ammonium chloride plus heat. We may write this heat like this also, on arrow. Barium chloride plus ammonia plus water. Again, endothermic reaction. After this, we move on to the fourth characteristics. Fourth characteristic is change in color. Change in color. These are the characteristics of chemical reaction. For example, if we take citric acid, found in fruits, when it potassium permanganate KMnO4, which is of purple color, purple in color, when we pour citric acid into it, the solution becomes colorless. Same way, sulfur dioxide, when reacts with potassium dichromate solution, potassium dichromate, this is orange color solution. Sulfur dioxide gas is passed through this potassium dichromate solution. It becomes green in color. This also shows the change in color. Here orange, here green color. Now one more example I would like to take here, that is ferrous sulfate FeSO4.7H2O. This is green color. If we heat this solution, ferrous sulfate, it breaks into ferrous sulfate, which is white in color, and the water molecule is written here. This copper sulfate, same way we can write CuSO4.5H2O, also known as blue vitriol. Color is blue here. When we heat this becomes copper sulfate. Again it is white in color, and the 5 molecules of water is separated. Now the fifth characteristics we move on is formation of precipitate. Formation of precipitate. Here in this case we take the reaction lead nitrate PbNO3 hold twice reacts with potassium iodide. It gives lead iodide, that is PbI2. It is solid, settles down, yellow precipitate plus twice KNO3 aqueous. This is precipitate is being formed here, therefore this reaction is also known as precipitation reaction. One more example, barium chloride when reacts with sodium sulfate solution gives barium sulfate BaSO4. Again this is solid, settles down, white precipitate is being formed here, plus 2 NaCl, that is again aqueous. These are some examples of formation of precipitate.